Okay, let's prove this by induction. So firstly we want to prove the first case n is 1, so the sum from 1 to 1, 3 or minus 2, that would just be 1. And does that equal 1 over 2 times 3 minus 1? Well, that's true. 2, we assume case n equals k is true, i.e. the sum from 1 to k, 3 or minus 2, is equal to k over 2, 3k minus 1. 3. We're required to prove case n equals k plus 1 is true, i.e. the sum from 1 to k plus 1 of 3 or minus 2 equals k plus 1 over 2 times 3 k plus 1 minus 1. So again, with these summations, the best thing to do is to start from 3 and sub in 2. So that is, you look at this sum, and it goes from 1 to k, and then there's an extra piece at the end, k plus 1. But the first part of the sum, the 1 to k part, you can replace it by this. So you end up with, on the left, the sum from 1 to k, 3 or minus 2. Well, I was going to sub it in, but I thought maybe I'd be doing too much one step. So you split this sum up into 2, plus, and then the last piece, which would be 3 k plus 1 minus 2. So that's 1 to k plus the last piece, and that's equal to k plus 1 over 2, and then we'll just clean that up. That's 3k plus 2. So this here we want to replace. So we get k over 2, 3k minus 1, plus 3k plus 3 minus 2, so that's plus 1, and that's equal to k plus 1 over 2 times 3k plus 2. Any cancelling? Nope. That's 3 over 2 k squared minus k over 2 plus 3k plus 1 equals 3k over 2 squared plus k plus 3k over 2. 1 over 2 times 2 is 1. So that would be 3 over 2 k squared plus 5 over 2k plus 1 equals 3 over 2 k squared plus 5 over 2k plus 1. So this is true. So 4 now. 1 plus 2 plus 3 means it's true when n equals 1, and then 2, and then 3, and then 4, etc.